Hi again. I am now on to 5.4 number 4 on page 282 in your textbook. The question here asks us to identify the coordinates of any local maximum or minimum values of the function y equals e to the x minus e to the 2x. So we should recall that if we want to find local maximum or minimum values, we need the first derivative, always. Derivative is the first thing we'll do, which would be e to the x minus e to the 2x times 2. Chain rule on that one. Let's just clean it up a bit. E to the x minus 2 e to the 2x. Is my derivative there. And now, picking up on the last point that I made with question 3D, the previous example, since we want to make the derivative 0 here to find any local max or minimum values, we'll want to common factor out the e to the x on the right side here. Now, just be careful over here. E to the 2e to the 2x divided by e to the x. I'm just going to write this on the side here. 2e to the 2x divided by e to the x, because that's what we're really doing when we factor, right? We're dividing out the GCF. So how do we actually do this? Well, e to the 2, the coefficient just stays where it is. The e to the 2x divided by e to the x is dividing powers with the same base, so we're actually subtracting the exponents, so it'd be e to the 2x minus x, which is e to the x. Just wanted to make sure I clarified that. Okay, next step would be to solve the equation for x. So we have e to the x equals 0. 1 minus 2e to the x equals 0. Does e to the x equals 0 have a solution? No, because you can't have a non-zero base to a power being equal to 0. That doesn't work. So no solution there. Over here we have 1 equals 2e to the x. Let's divide both sides by 2. To isolate e to the x, so that's equal to 1/2. And then we can use our method from 5.3. Just take either the log or the ln of both sides, but since it said power with e in it, makes more sense to take the ln of both sides, because then we have a property that we can apply that will help us. So ln e to the x equals ln 1/2. Going to the next page now. So we're at ln e to the x equals ln 1/2. For ln e to the x, we can either apply our property that says that the log of a to the x base a equals x, or we can apply a power law for logs from advanced functions, bring the exponent down in front, which would make it x ln e, and ln e is equal to 1, so it's still x. So either way, the left side of the equation is x. X equals the ln of 1/2. Now I'm going to get that as an approximate decimal just because I need to do the first derivative test to find out whether it's a max or min, so I need to know approximately where that is on the number line. So I just put it into my calculator and I get approximately negative 0.69. Now I do my excuse me, first derivative test, and if I evaluate negative 1, which is in the interval less than negative 0.69, you can just put it in your calculator. You should have a button on your calculator that either says on the calculator, you might have an E button If you don't have an E button, you might have an E to the X button. You might have to press second function or shift to use it if it's in the small print above a button. Mine's above my lawn button in small print. Just some tips there on using the calculator with E. So for x less than negative 0.69, so x equal to negative 1, I get that the derivative is greater than 0. And if I take a value bigger than negative 0.69, so let's say 0, then I get that the derivative is less than 0. So just put the numbers in and verify that for yourself. This would then tell me that when x is ln 1/2, my point here is a local max, but I need the y value that goes with it as well. So I'm going to do that on the next page because it's going to take a little bit of work. So when x equals ln 1/2, to get the y value that goes with that, I need to substitute it into the original function. So e to the ln 1/2 minus e to the 2 ln 1/2. Sorry, I keep hitting the wrong button with my arm. Okay, now we need to simplify this a bit. So the e to the ln 1/2, we also, from your useful list that you all posted on the class chat, have a property, sorry, let me change that, that says a to the ln x base a equals x, correct? So e to the ln 1/2, which is log base e, right? Ln is log base e, is just 1/2. And similarly over here, we can't apply that properly directly yet because of this 2 in front. However, we can take this 2 up onto the 1/2 and make it an exponent because of our power law for logs, which also applies to ln, of course, because it is a logarithm. So the e to the 2 ln 1/2 becomes e to the ln of 1/2 squared, which is e to the ln of 1/4, which is 1/4. Now, you could have also gotten that answer with your calculator if you just put in e to the ln to the 2 ln 1/2. It'll probably give you 0.25, but obviously you should recognize that that's the same as 1/4. Okay, so our final answer here is, let's just go back and remember that we got a local max for this point. So therefore, ln of 1/2, sorry, I should have had a negative here. I skipped a step. Let me go back. Okay. The step I skipped was that I found e to the ln 1/2 is 1/2, and I found that e to the 2 ln 1/2 is 1/4, but I didn't subtract them. I forgot to subtract them. So, wait a minute. Oops, sorry, confused myself. So I have 1/2 minus 1/4, which is 1/4. Turns out it's the same anyway, but we shouldn't skip that step because it might not have been the same. Therefore, oops, lost my page. Therefore, ln 1/2 and 1/4 is a local max. Now I'll tell you what, the first time I did this question, I actually got -1/4 for the y value. So I'm going to review it, and if I'm wrong, then I will let you know on the next sample question. But I think that I made a mistake the first time. Why don't you guys let me know? Send me a message and tell me which one you think is right here. +1/4 or -1/4 for the y value. All right, have a good day.